So what this final unit of work is about just recognising the difference between the statistical attributes, if you like, of a population, so the entire cohort, as opposed to the statistical attributes of a sample taken from that cohort. So I guess to put it in context, when we have a census, the government produce a whole heap of statistics on average ages and education and all those sorts of things. Because it's actually a census of the whole country, that's actually the population, the details of the population, as opposed to if we just sample, take a supposedly random sample of people and they're representative of all the whole country, well, that becomes a sample statistic. So our population proportion, the whole population, the sample proportion is just the results of that sample. Okay, so I guess they're the key terms, and then how we can use some different statistical analysis to analyze that data. All right. So first things first, what is the difference between a population and a sample? Okay, so the population are all eligible members. Okay, that's my population. And as it says here, it's impractical to deal with the total population, so we select a random sample instead. So a sample of size n is called a simple random sample. So I guess if it's completely random, it means that every group, every attribute that you're testing for is equally likely to appear as any other. All right. So a random number generator to produce a possible sample from these different people. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So if I select a random number generator, I can select random int 1 to 20 and comma 6, and that'll produce 6 random numbers. So you can see there that those numbers that I've selected are 1. Oops. So 1, 2, 3, 4, 5, 6, 7, 9, 20, and 10, 11, 12, 13, 14, 15. So they're the 6, make more sense to do it that way. They're the 6 people that my sample has generated using random integer. Okay. This leads us now to 2 definitions. One, the population proportion P. Okay, and that is the figure. That's the proportion of people in the whole population with that particular attribute. All right. So maybe the 20 people here is the whole population. Okay. And so if I look at, okay, well we'll get onto it. Okay. Whereas the population proportion P hat is the number in the sample with that attribute over the sample. So we're talking, it's kind of like a probability, but we're going to call it a proportion. So what proportion of the whole population have that attribute, P? What proportion of the sample have that attribute, P hat? Okay. My population proportion, P, is a parameter and it's constant. So we're going to take the population of always having that attribute, whereas my sample proportion, P hat, is a sample statistic, and it's going to depend upon the population, it's going to depend on the sample that I pick, and it'll vary from sample to sample. So for example, using my numbers that I picked up in my number generator, we already know, oops, that I had 1, 2, 7, 9, 15, and 20. So if you like, for my sample, for my sample P hat, the proportion of females I had was, well, Denise, Sharon, Georgia is 3. Oh, geez, I don't know if that Jamie's male or female. I think I'm going to give that as A. I don't know. I'm going to I'll call it male. I'm not sure, fellas. So Denise, Sharon, Georgia, that's 3. So my population proportion, P hat, is a half. So that's my sample proportion, okay? Whereas the population proportion, P, well, how many females have I got? I've got 1, 2, Miller, who knows? 3 for Jane, Teresa 4, 5, 6, 7, 8, 9. I'm going to say 9 and leave Jamie as male. So I've got 9 out of 20. So that's constant, P. So that's the proportion of people in the whole population that are female. Whereas in my sample, I got P hat equal to a half. Slightly different. And your sample might be different again. Okay? So just distinguishing the difference between a population proportion P and a sample proportion P hat. Okay.